I've got a Nano VNA, and I made a little fixture for it. I wanted to show it. First of all, just this is what the Nano VNA looks like. This is the one I have. I have the kind of the first version that came out. I think the newer one's a little bigger, have the connectors on the end or something, but they all basically the same. And this whole thing would work on any kind of equipment. Uh, there we go, a little more focused. The problem with these things, among other things, is that they have these SMA connectors on, which are wonderful. But you can imagine trying to connect a big old hunky piece of coax on that thing. You're just going to stress it. It's just, whoa, I just don't like that. I feel real uncomfortable with that. Also, if you want to connect other things to it, like a balun, you're going to test a balun. Well, how do you plug a balun into the SMA? The other thing about the SMA connectors is you're plugging stuff on, unplug, plug, unplug, and that'll wear that friggin' connector out. They're nice connectors, but they can only take so many insertions. And so a trick to do is get these little things. I call them thread savers. I've heard them called other things, but it's just a SMA connector, male on one end, female on the other. You screw that thing in there, and this allows you to plug and unplug and plug and plug things in it. And when you wear out that connector, which you will, you just throw that connector away and get another adapter, and it's a whole lot cheaper than the whole new VNA. Now here's the little adapter that I made, or the little test fixture that I made down here. So that's it there. Get this stuff, try to center it. I'm not much of a videographer, so forgive my only reasonable quality production here, and only reasonable quality camera. That's okay. It'll do. I'm talking about VNAs. I'm not talking about video production. Okay, here's the deal on this. I've got this is made with the PC board material, copper clad. Could be made with anything, piece of wood, it doesn't matter. But the trick on this is that I've got the thread saver and then an adapter that goes to a bulkhead. And on this vertical member here, I put a bulkhead, SMA bulkhead connector, just one of those. You drill a hole in the panel, stick the connector on there. I guess in this case it would be on this way. That way. And it put the nut on it to hold it in place. So this is a bulkhead, an SMA bulkhead, a little barrel that connects the bulkhead to the thread saver, which is connected to the Nano VNA. Everything's tightened, and there's actually an official spec for tightening SMA connectors, but if you just kind of finger tighten them, don't get carried away, that's generally good enough for, UHF, VHF, HF. You want to get into the real serious stuff, you got to get the right little tool, which costs more than the dang VNA did. There's a torque spec, and I try to focus that better. That's okay. Okay, now here's how this thing works. It's connected to these little connectors, and then you connect your thingy that you're wanting to test into these. These are just tighten them down with the screw connectors, and the spacing on this is such that this sits very stable. It's down, just the height is just right for it to match up with everything here. And the way this works is that whenever you want to measure something, like if you want to look at a balun, what's nice about this is you can put the balun just into these screws, tighten the screws down, and now you got a good connection that's stable, that's repeatable. If you got another balun you want to try, then everything is all calibrated for that. And speaking of calibration, whenever you use this, you've got to calibrate it. And calibration essentially tells the computer that the real connector end is not here but way out here, wherever you set it. So you go through you plug all this stuff in, go through the calibration procedure, and it compensates for the fact that this thing's really out here. There's a little bit of capacity, a little bit of delay, and so forth. And then the process of calibrating it, you have to put a termination there, and so I've made all the appropriate terminations on little jumpers here For instance, here is a short circuit. Get a kind of a close-up of it here. So that's a short circuit. You can see that the, I just put a label there. So the wires just go in and go around like that. What's this one? This is an open. And you want to plug, you want to make this. You want to have this same thing that looks like this. Because an open circuit is an open circuit, but it also, they have to compensate for the wires going to the open circuit. So whenever you have an open circuit, don't just disconnect the connector. Put whatever kind of open circuit, whatever kind of connector you're going to have, only have it be an open circuit. And then a 50 ohm load. And I made a little 50 ohm load, and you can't really get a 50 ohm resistor, so I put 200 ohms parallel in there. And then a little surface mount, 1206 size. I think they're pretty easy to work with. Or you could put through hole resistors on it, it doesn't matter. Okay, now for the through, those are all, you know, if you for like S11 for return loss and measurements. If you want to do through, that is the gain of something, then you have to have connectors from this side to that side, from across. And so this is my little through fixture here. And it's just the right size, so it plugs into focus. There we go, into this guy. So there we go. And then now this is all very stable, very strong, and then you can plug in more SMA or stuff into there. Or if you got a BNC connector, or like for instance with our big fat coax here, this big fat thing here, instead of plugging it in there and breaking the SMA connector, you put it this guy. If I can get it focused. So just made that. That's I put this in the junk box with the connector. Just goes with it, and then that plugs on here. Screw it down, and now you can put your big connector on there. And if you really, you know, you could stabilize that more if you're so inclined. But this will hold that thing. It's not. But the nice thing about this, if something breaks, it ain't gonna be the VNA that's gonna break. It'll be these connectors or something out here. So anyway, so that's my, and then of course you can put, anyway. Okay, so that's my little VNA adapter. Have fun, enjoy, and use my ideas and plug them in with other people's ideas and come up with your own. It's good fun. Anyway, 73. Catch you later.